But also, I'm going to pass it off to Jon Manwaring, who's going to share a little bit about what we have in the Nova studio, and then we'll hear from everyone else. So thanks for being here, everyone.
Great, thank you. This is one of the things that I do here at the university that just pleases me, and I really enjoy it, and it allows me to connect with lots of different people on different topics, and hands-on creativity. So I love that. So I appreciate being invited to this as well. Um, let me just quickly introduce I guess the idea of the Nova Studio. It is intended to be a space where we start with the idea of technology and share it uh, with both students and faculty so it can add to I guess, their toolbox of possibilities in their classes. A lot of times we'll see people wanting to express their ideas from an assignment in alternate ways. So with that being said, the Nova Studio isn't the uber ultra makerspace, but it is the best place to start regardless of what discipline you're in. And then it can lead to other things, um, where you might want to get deeper into making technologies or very specific innovation for your curriculum. But it is a great place to start, particularly for undergraduates. It is located in the Spark building. Let me just share my screen here real quickly. Um, it is located in the Spark building, and you can see it is purposely co-located with a lot of different classrooms here. It's also very visible. It's on the north end of the building. Lots of people walk by, and both on the outside and near it when they're walking through the building. It's right there. It's on that first floor. It's named the Nova Studio because of a project we had with a, a Comstrat class where the students worked through a design process to brand and market the studio to undergraduate students, and they chose the name. So we've kept that. Um, it serves any discipline, and anyone is invited to come in and experiment with the tools. We have a lot of different tools that you can experiment with, uh, including laser cutters, 3 different types of 3D printers, some hand tools for various processes that are affiliated with that, laser cutters, 3D scanners. This image right here was created with 3D scanning technology, and we have made these things as widely available as we can to both students and faculty. So it may seem intimidating, but we have ways that we can ease into it with low entry of investment in terms of trying to learn the technology. And from there, you can go as far as you want. The sky is the limit in terms of going deeper into it. We do have a certain amount of funding that we use for undergraduate student projects because we don't want that to be one of the elements of that's a barrier. So we don't allow for any type of creation unless there's a specific connection to curricular type of work. We're not cranking out T-shirts for student clubs or things like that, but where it touches the possibility to learn, and it allows for an alternate expression of an assignment, we are there to partner, and we want that to be a seamless transition, as you consider allowing that in your course. So with that being said, I guess I will talk a little bit about just briefly, some of the things that we've done to give you a little bit of an idea before I turn it over to Mary and she can go very deep into her work, and then Hallie. Um, we have done things where we allow students to scan, like with this tool here, different things that's related to their courses. So think about where you're doing something in civil engineering with BIM technology. This is an easy way to start that process. You can tag things in it and things like that. We have worked with faculty on laser etching onto objects. So there's a process where maybe you need to research some material. Those artifacts then get put onto the object. We work with the students in understanding the technology. Um, it's definitely not on you to know how to do all these things. We want to partner with you on it. But we do want the students to have that experience so they can add that to their toolbox and say that they have some amount of proficiency with that as they move on to the next thing, or if they want to explore deeper into it. So that is definitely the flavor of what we're doing in the Nova Studio. We also purposely partner with the other maker spaces on campus. So when you are ready to do something bigger or more discipline specific, there's an easy pathway for students to go from one place to the other. And then they can have some consistency in terms of understanding what the software can do, what the cost of materials might be, and what the scope of work might entail, if they want to do something at scale. So what the time commitment might be. And we also share technical expertise across those spaces so that we can seamlessly pass students from space to space that are working on the projects that you're wanting them to be able to do in your course. So that's a lot of information. I feel like a lot of what happens in the Nova Studio is best explained through examples of what's been successful, and also opportunities to come and look and see for yourself. So we are very open and would love it if you wanted to stop by and just say, I want to try to laser cut something, or can you just show me what this 3D print means? And we can talk about what that could be interpreted to for an assignment, and how that might scale. Examples like that. So I invite you to come, and also to reach out, and we are happy to work with you and share everything that we have and everything we know, towards allowing your students to have these hands-on experiences and alternate ways to express themselves. So I think that's a lot for a start. Please let me know if there's something I can qualify or add to. But I want to at least leave my part of this presentation with just an invitation to come and see. So with that, I'll hand it off to Mary.
Thank you, John. And I can say that everything you said is true because I could not have done any of this had we not gotten such a huge amount of help. So I'm gonna share my screen here and talk about the project I'm doing, and hopefully people are seeing. Oh, I'm gonna turn that off. Okay. Hopefully people are seeing the screen now. So talk about what we've done in that space, which I have actually thoroughly enjoyed over the last many years. And so I'm going to start with, how did I start? And it's ironic that the person that really helped me with the start is one of the presenters today. So sometime way back in that pre-pandemic world that we had, at Academic Showcase, Hallie was giving a presentation on her use of 3D printing in this space. And I stopped at her poster and said, tell me more about this. This is so cool. And she went through everything. And I decided at that point I had to do something with this in virology. And so the course that I have is general virology, and our MBIOS 442, and most people would think that's not an engineering class, and so why would you be introducing this in a general virology class? The 3D printing. So one of the things we've done for years in this class is we break out into small groups of 3 to 5 students, and the class itself has ranged from 35 to 50 or 60 students, depending on the year. More recently, it's been on the lower side, 35 to 40 students. So we've got small groups. They work together all year long, and we work with these small groups on the 3D printing itself. So let's talk about that for just a minute. So why first do 3D printing in a virology class? It's not engineering, and that seems like the practical place to be setting these things up. So one of the first things is holding a virus in your hands, which you can't do in real life, they're too small, allows you to understand better what we talk about in terms of the structure of viruses. What do viruses look like? And so the students, I don't assign them a virus. I tell them they can do any virus they want. And in fact, if they want to create their own virus, they can create their own virus and give me the history of their own virus that they are making up. I've only had one or two groups go that direction. Most of them go with a real virus. But what's amazing to me is every single year, the students choose all different viruses. I don't assign them a virus. So each group decides on the virus that they are going to work in to create this 3D printing. None of them have backgrounds in 3D printing, and I'll come back to that in just a minute. But just in this picture, we see an Ebola virus, we see a plant virus, we see a pox virus. Literally, the students are all over the map in what they're doing. The other advantage is that I ask the students to do a presentation to the class. They both write a paper about their virus and they present it to the class. So not only is a single group holding their virus in their hand, the whole class gets to see that in the discussion. And because by just the different interests in the class, they are all holding different viruses and they've all done different things. The other fun thing is some of the students go one step farther. They don't just want to know about the outside of the virus, they want to know about the inside. And so they print their virus in parts so that they can have two halves and then what goes on the inside. So this one's a herpes virus that this student is holding, and he's showing us that there's still another shape on the inside of what's on the outside, and the students could talk about that. The interesting thing about viruses, and partly because they're so small, is that the structure of the virus relates to the function of the virus. And so that's another part of what they get to do when they're looking at these viruses. They can ask themselves questions, and even those of us that are listening right now that are non-virologists, and by the way, if you didn't notice in some of the pictures, we have frequent pictures of Chris, who is our main helper here, and we see him here again, and he was in one of the previous pictures. And I'm going to bring that up because that's one of the wonderful things about working with people in the studio is that these guys are there helping and holding our hand. But I'll come back to that in just a second. So getting to structure and function, even if you don't know anything about virology, you can look at these like wonderful knobby things that's on the tops of these viruses that students are holding. And you could probably take a wild guess and say, I'll bet you that has to do with the virus and how it grabs onto a cell and gets into a cell. And so those are the kind of discussions you can have about the function of the virus as you're looking at it. And as you can see, these students all did the inside too. And so we can talk about the contents of the virus that goes into the cell, and they've got it. And this one student, you can see their group even labeled all their parts, which I thought was kind of fun too. And again, all different viruses. Nobody does the same. So everything is just a little bit different. The other purpose of the assignment is they learn more about just one virus of interest. And so it allows them to go in depth. We've covered some concepts, we've covered them generally, but now they're going to take them specifically and apply them to the virus that they're learning about. And we can see still, once again, different viruses. I think this particular year, they needed to get rid of some of the black in the 3D printing lab. And so we saw a theme of black rather than the multicolors we saw in prior years, because it was something they had a lot of. But again, we can see viruses that infect bacteria. We can see viruses that infect humans. Again, all different viruses that they've selected to talk about. And again, same sort of thing in this picture. And then the last reason that I've had this assignment is these are life science students. And from the very beginning, when I asked the question, how many of you are familiar with 3D printers? In the first years, it was none. I mean, zero. Nobody was familiar with 3D printers. In more recent years, I might get 1 to 3 hands in the entire class. And guess what? 3D printers are a part of so much of what goes on anymore in society. They're things, they're our body parts when we have them replaced are often printed up on a 3D printer, knee implants and so on. And so not having experience, it just seems to me like that's something they should be exposed to. And the wonderful thing about working with Chris in the studio and John as well is that they help you through every step. You don't need to know the programming. You don't need to know all the details while still doing it yourself. So the students still go in and create their virus using a pretty simplified approach, a program, but it's fun and it's doable for them. And then they can print up this virus. They get to see a 3D printer. And I think those things are just as important as learning about the virus. I've got 3 kids in different fields. 2 of them have their own 3D printers at home, and one of them uses a 3D printer at work and will probably have one at home before it's all said and done. That's the world we live in. So I think it's an important piece of what we do in the class is familiarizing them with the technology that's out there. And again, another 2-part virus. And this one, though, I want you to concentrate less on the virus and more on the students' faces. And again, on the students' faces in this picture. And it comes to the last reason of why I do a 3D printing in a virology class. And I think that's really important too. Learning should be fun. And what we do, if we can bring an element of fun. So there's not a single year that goes by that the students don't say, we loved the 3D printing. And so I think this is a wonderful opportunity. And John and Chris in that lab, Chris comes to every one of my classes, or comes to class every year to talk about the process. He makes it easy for the students, and so it is fun. It is a learning experience, and it's something that started out maybe kind of scary, but they make it easy, and so it's something I've appreciated. So that is what I've got. Thank you.
Those are so pretty. I want one. Chris, I'm going to come down and bribe you to make one for me. Thanks so much for sharing. Hallie, do you want to share? And then first of all, does anybody have any questions for Mary?
Yes.
I do.
Thanks, Mary. This is Naidu Rayapati. I'm a faculty member in Connors. I'm located outside Pullman campus, one of the research and extension centers in Placer. I do teach an undergraduate class, specifically talking about a variety of disease problems in fruit crops. That includes bacteria, fungi, nematodes, virus, etc. My question is, it's an interesting concept that I'm thinking of how to introduce this 3D printing. So the question is, what is the cost?
So, and that's one that I recognize can change on an annual basis. But so far, the very first year, the department paid and the cost was pretty small. But since that time, the fund that John referred to earlier has paid for the printing in the class. Now, I don't know if that would change if we had, so I said I had about 35 or more students in the class, but in terms of number of structures printed, it's based on per group. So we're not printing a zillion structures. I think if you had a large class or that sort of thing, the dynamics might change. And that's a conversation Erica, John, and Chris would have to talk about. But for us, it has not cost us anything since the first year.
Thank you.
Any other questions for Mary? We'll continue on then, but as you have questions, there'll be more time after Hallie presents, and you can also pop them in the chat. But Hallie, we'd love to hear from you.
Great, thank you. And so thank you so much for the invitation to present today. And Mary, that was a wonderful presentation. I really enjoyed seeing what you've done and contributing in any way that I did. So I don't have a PowerPoint. Instead, I've got lots of toys that I wanted to show you. And so I teach in the history of art, as everyone said. I teach ancient art history, that's my specialty, through to contemporary. But my focus is large lecture, or I started focusing on large lecture classes. And so part of the issue for me is that there's no art museum here with ancient objects. So we have a great museum, but it really starts the earliest pieces from the 1750s, I think. So to mitigate this problem, or this challenge, I had 3D printed objects of pieces from antiquity. And so they started out really small like this. This is a bust of a deity. And you can see that people here who were printing them, they were concerned about the color. They wanted them to look like flesh tones, I think, because they were concerned when objects like this one. This is a Nike of Samothrace, and she's vivid green, neon green. And so I was told this did not look like an ancient piece. And this is interesting, and I'll come back to this because I'll talk about color and the kind of iterations of this project and how it evolved over time. But so I started with these small scale objects. And you can see, again, this is the bust of Nefertiti. So they are bleached white, which is very unlike their pieces that exist today, how they're preserved. I started to get a little bit larger so that students could see the pieces and kind of think about the use of space and how, if it's a large sculpture, how that would relate to the user. And if it's three-dimensional, what did the back look like? These kinds of ideas. And so I use them largely for introductory level courses. And you can see we got much larger. This is a double-sized print. So there's a line here where you're basically limited by the size of the printer, the bed of the printer. And so this one was printed, this is one piece, and then this is a second, and they were joined together. And so you can see this is Laocoon and his sons, and it's been reproduced in antiquity and today in many forms. And so there are texts that relate to this object, and then again, the actual piece. And so there was a lot that we were talking about in class, and people could see the pieces without having a field trip to the Vatican or wherever these pieces are housed. And so we got larger. And then what I ended up doing in some of my upper level classes is now I'm teaching another course, which is introduction, or yes, so it's Roman art and culture. And so most recently what I did was I had students think about particular artworks, sculptures, and we were talking about polychromy. And that means the colors, multiple colors that were used to paint these objects. And so I really think, I talk a lot about the bleached white statues and how that was not at all what they look like in the past in many, many cultures. And so what I've done is I've had students painting these objects. And so that's another interesting art form because you get not only digital literacy, but you also then have questions about what does it mean to have a skin tone, right? So thinking about biased ideas about different people and races, but thinking about, in particular, multiple interpretations about reconstructing objects based on the data that we have. So what I've been doing most recently is having students look at a variety of primary sources, primary visual and written sources about certain deities or object types. And so students get really creative. You can see here, there are different images or different images that they've pulled from mosaics and coins and all kinds of formats to think about the colors that the objects would have been in the round. So you're looking at the shield and the aegis, which is this part, and then more examples. This is a kind of Anubis figure, so an ancient Egyptian figure. Again, thinking about what the dress might have looked like, thinking about the accoutrements, right, the other objects that the figure's holding. And I have students who work on Eastern and Western objects. And so you can see just a range of interests, what they were pursuing. And often what I do is I have them work on two pieces. So, I mean, two examples of the same piece, but two different competing interpretations. So this piece, for example, they might have reconstructed it one way and then another. And so they'll show us the two possibilities and then have a presentation based on that with, again, primary and secondary sources. What were they thinking about and why? And it's really engaging for the rest of the class as well, because the students talk about their interpretations, and it's very it's one of the few ways that I've had that students actually critically engage with scholars and think about, well, I don't agree with this one part, this other part seems very convincing, and then they get to put it together and think about how maybe a third alternative or even two competing alternatives is not something that I've had students really get to that level before I started with this project. So it's been really helpful in that regard. And then what I've also had the great privilege of doing in more recent years is in 2023, I pursued some funding, external and then fortunately internal as well. And I brought glass blowers to campus. So my focus is ancient Roman glass, but also contemporary glass. And so I had people coming from the Tacoma Museum of Glass. It was the International Year of Glass. So I got some funding from the United Nations for that and then elsewhere. And what I did was I had an event where I had I partnered with the museum and we had discussions about ancient glass and what that might have looked like, and then the chemistry of glass and the engineering to do with glass. And then we had the glass blowers create and think about different interpretations to creating ancient glass, like how would they've been approached. And so the people in the Spark were great, and they produced, this is a 3D printed glass vessel, and I'll show you what it looks like in just a moment in an interactive app. But they made this, and then there's a contemporaneous at the same time. This piece was made of glass, and then this is a metal collar, which I'm not showing you correctly. You'll see it in just a moment. But basically, this opens and closes, and the real one does not open and close anymore because it's been basically like this since the 4th century CE when it was made. But with this, students and everybody, the public, were able to actually manipulate it and see how it was meant to be opened and closed. I'm fascinated by the history of making. I just find it really so captivating. And so that's what my scholarship is on. And so this was the basis for the event. So I'll show you now, I'm going to share my screen, and I'll show you the interactive app that I was able to make with the third really important player, in my opinion, at the Spark, and that's Mary Packer. Let me make this larger. Can you see my screen?
We sure can. Thanks.
Okay, brilliant. Thank you. Okay, so so this is an interactive app, and it's called, it was made using Articulate. And what you can see is you can click on the buttons, right? You touch it to explore. And this app was available to everybody at the event. And it's also useful now because in my classes, I can refer back to it and have students engage with it. And I've got assignments that are based on this. But what you're seeing in the center is the only surviving image of ancient Roman glass blowers. And so this dates to the 1st century, and you can see this figure with the blowpipe. So he's making glass, and then his assistant here is putting away a piece of glass. And all of this is again to do with glass blowing. This is that piece that I just showed you that was 3D printed. And so when you click on it, you can see all kinds of information. Mary was a delight to work with, very patient with me. And you can see you click on these buttons and it takes you through the object. And so when you click on more, right, certain things are bleached out, and then you can click to see different parts, which is what I wanted. And she was able to do just brilliantly. So you can see you can click on more and you can get more information about each of the parts. There are so many it's really interesting, the kind of information that I was able to convey and really visualize so clearly. And so you can click on things, right? They get larger. And then this is a GIF that Chris made. So you can see the actual manipulation, the opening of so that's an ancient screw or ancient nail. And so that part would have opened and closed, and that's how they fastened it. And so again, just really extraordinary. When you're teaching pieces, you know, from 2 millennia ago, I just thought this was brilliant. It was a great, exciting way to show so many different concepts all at once. And they also made these maps. So this is a really interesting piece. It's like, so basically what you would have seen on a caravan route. So if you imagine this is an ancient parcel like what you get from Amazon or other places today, it's the same idea. And so this is the basket tree that was meant to preserve it so it didn't get broken, the glass piece didn't get broken. But so it comes from Syria, and so you can see here we've got the little WSU logo and then moving on the globe to where the piece was probably found. And so again, all of this was done with the Spark and their assistants, and they do such a wonderful job. It makes all of my work look great, even though they're the ones doing all the technical side, and I really appreciate that. And so again, it's just so much fun, and it makes it very, very easy to use, and it's fun and interactive. So you can teach with it and just do so many things with it that are just really engaging and exciting. So I think I'll stop there.
I want to take your class. Any questions for Hallie? Hallie, how long did it take you to put that Articulate website together? What did you start a year in advance, a semester? What's the time scale?
I'm trying to remember. It wasn't that long, and I think it was we talked about it maybe like a good 6 months beforehand, I think. And that was, and I might be mistaken, I might be shortening the whole period, but to actually like actively get the first draft where I had the content, and then Mary was able to work with it and then start, kind of making mock-ups and things like that. I would say that was maybe 3 months, the most.
I'm like looking at that and thinking, is this is such a naive question, and I guess this was for Chris and Jon and Hallie and Mary, but when I look at that Articulate website and I think about all the things that students can explore, it also makes me think about Mary's example with the virus. And so could a team of students collaborate and make something in Articulate where they could go in and investigate something that's invisible? And then I mean, would that be too hard for students to do, or what? Any thoughts for Jon and Chris
I
and
guess I'll
Hallie?
volunteer Chris and Mary's time because it's easy for me to do that. But I feel like that is a definite possibility. And I've seen Chris work with undergraduate students and grad students on digitizing physical artifacts that then you could take into space. And then you could create information around that, similar to what you've seen Hallie share there. So I feel like that is definitely a possibility. I think the first question is, well, what is the thing that you want to bring in? And then start talking about how the story is told. And I'm sure Hallie can attest to this. With her work, there was a lot of conversations about, okay, this is a very complex object. Does it exist anywhere? Is this something that has to be created from scratch? Can we scan it? Can we get good enough pictures of it that then it can be an artifact in Articulate? And I think we went through some very healthy conversations with that. There were things that, we were like, oh, well, I mean, we could do it, but that's going to be, a 2-year project. And then there were things that were like, well, this is achievable. And if you go back to look at the Cage Cup example, I'll use that as a specific example. There is no known 3-dimensional scan of a Cage Cup that we were able to find anyway. Lots of pictures, some of them not great, some of them okay. But ultimately, Chris took what the artifacts that he was able to find, and he created that himself into a 3-dimensional thing that you could then use in Articulate. But we do have, a little bit easier path is if there is a physical artifact, then we have a tool that allows you to just scan it, and then it becomes something that's you can manipulate in the digital world. So I think it really is all about the conversation of what are the things that you want in there. And I think we will walk through the possibility and the time it takes to do it. There's always the good, better, best. And I would love, if we just did everything like totally the best and we could spend all our time on it. But I also, there's what is it going to be in the end? And is it going to be something that students can manipulate? And is that going to be good enough? And so it's a good conversation to have. And I think we come to a balance on those things.
And I would agree. And I would one thing to add, in the years that I've been doing this, I started out and I don't think that many people were doing what I was doing. And so I was approached by the Scan the World project, which is an international project where they do a lot of photogrammetry, which is basically people with phones, right now phones, that you'd go around an object in a museum space and then you'd upload your data, your files, and then other people can use them to print the same object. And so now that's something that's much more common. And like Mary was talking about how common it is to use 3D prints in general, and like libraries have them, right? So it's much more common. But it also makes it a little easier each time you do this to then go on to the next iteration. And so I have the privilege of being in an art department. And so we recently, I had pilgrim flasks. So again, from like the 4th and 6th century, they were printed, 3D printed, by my department, because now we have more of their toys in our department. And then we did a metal pour based on that particular object. So we used it as though it was the real object from antiquity. And then, you make a negative impression, and then you cast the metal. And so we have aluminium versions of them that were, again, students could see what they actually look like. And so it's really, there's so many different ways that you can go. Once you start with this, it becomes easier. And now in the Smithsonian, for example, has a number of files, and now it's so much more common in the Harvard and just like the British Museum. So many museums have the STL files, which are those files that you need for 3D printing. And so they produce them. Students in digital fabrication do them more often. I had another exhibition with a colleague, and he had his students actually produce 3D printed objects that they made. So they designed them and made them. And then I had mine alongside them. And so there's so many different directions that you can go now, that this just really mushroomed, I think.
Well, speaking of tools, Chris, do you want to give us some further insights?
Sure. Just going to share my screen since we've been talking about them. I have them right here. So this is the cage cup. Again, this was, I just made this on, just reference images and things like that. And so, this one obviously was a little bit more complex and just managed to make sure it was correct. So this took me about a week to make. And again, I can just kind of going off what John mentioned, there wasn't already an existing STL file that we could print from. So this one was kind of the full gamut of the process of actually creating it from scratch. But if there's one already existing in the world, we do have tools in the design studio that can digitize objects. And I'll have an example of that I'll share here in a minute. So again, normally the process is a little bit quicker, but for something very specific like this that, is almost mechanical, that everything has to be the correct scale, it did take a little bit longer than normal than a scan would. Scans usually take a couple of minutes. This one took, again, about a week to create. And so we ended up just taking this and just printing it out in one of our printers that prints in powdered nylon. So it melts that nylon into that shape. It's a very robust production printer. And so these are the type of tools that we use so that way students can put hands on and they're not worried about breaking things and not actually destroying the actual artifact. We've ended up doing probably 150, 160 scans for anthropology and vet med, scanning all their bones and then actually 3D printing them so students can drop them. If it breaks, we just reprint a new one. So it makes the process much more streamlined. And of course, we have the viruses. These are just a couple of examples that students have created. I made these, but I show students how to make these. And so I will end up going to that class and then kind of giving a quick demonstration. And then I meet with those teams in the design studio and I show them how to create this using an Autodesk product here for the software. And the idea is not to teach them how to 3D model. That is not the point. They're just importing these basic shapes. It's just a click of a button, like this middle section here is just creating kind of that and then moving everything into position. And again, the idea is not to teach them how to 3D model, but more understanding how the components work within their virus. So if they want to do something a little bit more complex, like cut spheres in half, things like that, getting them, a little bit more in depth by putting other objects. There are tools that I show them, or I will do that portion for them if they want to get a little bit more complex with it. But, the whole process, I meet with each team for about an hour, and within an hour and a half to 2 hours, they're done with their virus. So it's a very fast process, low learning curve. Again, it's not about 3D modeling. It's not a 3D modeling course. It's just creating their virus that they want to print. And then we print one per team just so we can have everybody have their print done in time for presentations. And then if students are interested in having their own, then we print that after that presentation is over. Questions on that? Okay, because I got more. So just kind of carrying off what John was mentioning, I think we've kind of already seen this picture, but I had it on the ready. This is the first one that we did for the first class. And so again, there's various different virus types there. And we started it in spring of 2020 and been doing it ever since. But I'd like to bring over this one here. So this is a tool that we have that actually does Google Street View.
Chris, your screen isn't changing.
On my screen
We're
is
still on the original, or at least I am, for what I'm seeing, still on the original picture with the pot and the different pieces of the virus.
oh really?
Yep.
At least that's what I'm seeing.
Same.
Okay, let me drop one more time and then how's that?
So we didn't see the class afterwards or the one after that.
Okay. Can you see the screen now?
Yes.
Okay, perfect. So there's the first class that we did for the virology spring semester 2020. So yeah, different viruses there. And again, some of these are split in half. And again, I show them, or I do that type of tool that would take that to be able to do that. But most of them were just solid shapes that I showed kind of there. And then for this one, so this is a tool that John was mentioning. So we did Google Street View. Essentially, we have a tool, a camera that does that. It is a LiDAR camera. And so we have the entire walk from the Spark to the Chinook all the way to the Pride statue. And so I'm just bringing this one to attention because on the side of the building for the library, we have the reader on the side of the building, and we use another tool we have a handheld digitizer, and we used a vacuum former to create a mold of that after 3D printing it, and we made chocolate bars. That's kind of hard to see. So we worked with hospitality and we partnered with them to actually have them pour the chocolate for us within that mold that we created in the design studio. So we ended up doing 2 events that's been very successful with these. We'd actually like to move these closer to a production where, maybe on game day, somebody can pick up a bar for $2 and they got a chocolate bar of the reader and a little WSU memorabilia when they leave campus. But also, again, we have the inside scanning of the Bryan Clock Tower. So again, this was just something that we did with the students as a partnership under the Creative Corridor umbrella. And students were able to gain, normally they don't gain access to this space, but during this project, the students will be able to walk in there and actually digitize the entire 3 floors. There's actually one more. We haven't quite finished it, but the entire Bryan Clock Tower. And you can actually navigate through this as if you were actually in the space. So this is going to be part of our campus walking tour. And again, where normally you don't get to see the inside. And that brings me to this space. We ended up partnering with a couple of classes as well using the same technology where we scanned the entire downtown during the construction project. And students had select businesses that they would reach out to those businesses and gather information to put in as metadata into this scan. So each one of these little matter tags is what they're called. Students gathered that information from the owners, and you can navigate the entire downtown. So again, we have 2 scans actually. There was a bookend to that where we had the scan prior to the construction and then after construction. So it was a 2-part process. And again, John and I went with each team and they did their section for each team, and then we moved on to the next team. It was a very long day, but I think it paid off. It was a great experience for the students.
It wasn't that long. We stopped for nachos.
Yeah, that's true.
And let me just let me interject real quick.
Yeah.
I do see there's folks here from the other campuses. We are not we don't let ourselves be place bound by the technology. We have worked with faculty on the other campuses to do similar projects, and we would be happy to work with you as well. Certainly, you know, if you want your students to have this experience, we would love to partner with you. If you're doing something similar to the process that Mary described, that's certainly doable. With your class there, I mean, it's really a two-part process where, you know, there's 3D modeling that Chris walks your students through that's very simple, and then there's the production process. And it would, we can certainly conceive of ways to be able to support you. So don't feel like, well, my campus doesn't have this. That is not a limitation. Happy to find ways to work through that with you, and I'm sure we can be successful.
Agreed. Yeah, and again, this is how we did some of the walking tours for the buildings on campus. Obviously, this is one building, and we've done it for Spark as well. And so, again, either I or my staff will go out to a location and kind of do the training on the camera. So it's kind of the hand holding all the way through. You as the instructor doesn't have to know the process. Either I or a staff will do that. Yeah. Any questions on that?
Any ideas bubbling up?
There's a lot. Again, we have chocolate bars.
Well, you had me at virus, but a chocolate bar isn't going to get me as sick. So, well, this is really exciting. I really appreciate the time that you gave us to share your innovations. I wish I was as creative. I'm going to endeavor to do one creative thing this month because I feel inspired. If there aren't any other questions, are there any last shares that any of our panelists want to provide for the group?
I guess I'll just
Well, if
add.
there are any questions, I'll put my email address in the chat. Feel free to email me, and then let's just strike up a conversation if you have something later.
And I just wanted to add one thing. So I can say, because I've worked with them for many years, everyone in the Spark is fantastic, very approachable. John, Chris, Mary, just really ideal to work with. So if you have any inklings of an idea, something you're really excited about, and just kind of don't know how to pursue it, I would just suggest going to chat with them, and something will probably emerge that you didn't think was possible.
I second that. They make it so easy. You know, I don't know much about what my students are doing myself. They do it really well with Chris, and I appreciate that so much. Thank you.
Very kind of you, and it's only our pleasure. This is just the best part of working here in the Spark, is working with you and your students on these projects.
And I will say, stay tuned for next semester. I'm hoping to invite Ray Olson and Mary Packer to come and share a little bit more about Articulate, which is what Hallie used to make that website. Mary Packer's been collaborating with Ray to create an escape room inside of Canvas for their entomology course. So really, what has been shared today is just the tip of the iceberg. If you have an idea that requires technology, chances are Chris, John, or Mary will be able to partner with you to bring it to life. Yeah, Rachel Halsey just said we also use Articulate in vet med for the diagnostic challenges. So it really gives an immersive experience for students. Oh,
and let me just comment on Julie's comment. Julie, I think that we could find something really fun to do, and I will just share very quickly. We are working with a history professor on a project where they previously were required to write a research paper, and now instead of writing the research paper, they do the research and they're required to laser etch they're artifacts on the surface of a ball.
I love that.
So
That's awesome.
it could be anything. I mean, it could be, very germane to your specific topics, or we could certainly have fun with it.
Well, I typically teach sections that are loaded with engineering majors, and God bless them, my mechanicals need more hands-on opportunities. So
That would be such a great way to bring that group in, is to
yeah,
have
I
a,
love that. Okay, I'm going to be brain picking you guys for the rest of the semester. Thank you.
Well,
Yeah.
good.
Look forward to it.
All right, gang, I'll give you 8 minutes of your precious lives back. Thank you for joining us. And again, reach out. We're here to support you.
Thank you.
Bye-bye.
Thank you.